Okay. Good morning, all of you. Today we have to perform the impact strength of different specimen. Different specimen, that is mild steel, brass, and copper. According to our requirement, we have to calculate here the ISOD impact test and Charpy's impact test. This is our impact testing machine. What is the basic difference between the ISOD impact and Charpy's impact? Before that, we have to study here how it can be calculate our impact strength. We know that what is meant by impact? Impact is we have to apply the large amount of force within a short duration of time, isn't it? And what is the basic difference between the ISOD impact and Charpy's impact? In ISOD impact, it totally depends upon the position of our beam, whether our beam is cantilever beam or whether our beam is simply supported beam. So once we have to consider the ISOD impact test, we have to set our specimen as a cantilever. And if you see here, this is our dial gauge, and if you see here, the dial gauge 1 division equal to 1 joule. So for that impact strength, we have to calculate here impact strength, that is nothing but energy absorbed divided by area of that specimen. But which area you have to consider? Now see here, because of that impact, we have to require different type of specimen. Now see here, this is our different specimen which is required here. One is for the mild steel, isn't it? If you see here, this is our mild steel bar, and one groove which is there, which is now here, which is important, how it can be calculate the area of that notch. Now see here, this is our specimen. Are you see this? And by using the vernier caliper, you have to measure the dimension, that is the length and depth. Depth for that you have to require, you have to consider below that notch. The importance of notch, which is important, the notch criteria is very important here, because whatever hammer we have to apply here, the position of hammer, which is exactly we have to require one critical point, and that critical point and the position of hammer, which is exactly suddenly applied here. That's why we have to require here notch. And according to that, our the ISOD and Charpy's impact here, if you see, the notch is V notch and here U notch. So that's why the position of your beam, it will be like that, and the hammer which is applied here, isn't it? Now see here, this is our mild steel, this is copper, and this is brass. Okay, so first of all, you have to measure the dimension. Similarly, for Charpy's impact, we have to place our position of that specimen, that is as a simply supported, and the hammer which is backside of our specimen, we have to apply here, and that is suddenly applied. So we have to check here the impact strength of brass material, copper material, and mild steel material, which one is preferable for our constructions. So we have to check here the behavior of material. Now see here, this is our impact testing machine, this is our dial gauge. If you see here, this is 1 division equal to 1 joule. So naturally this, the energy absorbed during the impact we have to consider here. Now see here, the dial gauge, it is just opposite. So for ISOD impact, 0 which is set here up to 160, and for Charpy's impact, 0 here up to 290. So maximum is 300. If you see here, this is 300. That's it. So why the maximum capacity of mild steel bar is 300 joule. Clear? And the another condition, once we have to apply that hammer, the position of hammer is also important here. Okay, which is exactly 90 degree for ISOD impact, and similarly for Charpy's impact, which is applicable or which is applied at 135 degree, isn't it? So it is just simple 1 division equal to 1 joule. You have to measure here how much amount of energy which is absorbed during the application of that particular hammer. Here, fix कर दो specimen. You have to just note down your reading, just applying. Once you have to apply that hammer, it is suddenly released because it is our suddenly applied load. That's why we have to calculate here the impact strain. That's why we have to calculate here the toughness of specimen, isn't it? And that test, which is also called as our dynamic test, because the hammer is movable. So dynamic test is there. And we will see here whether our mild steel material which is stronger than the other material by using that. So first of all we have to check here isodena set karo. Now the condition of our the setting of arrow, that is also depend. If iso test is there, it is just opposite, means it is goes on reverse direction. If we have to perform the char piece impact test, we have to exactly match our the dial gauge exactly at 0. Clear? Now the one more precaution is there. This is our dynamic test. So we have to release the hammer. It is just the specimen which is break into two pieces, and we have to check it whether it is exactly break into two pieces. Once we have to apply this suddenly apply. Now see here the reading is first is 300. Now it is 260. So you have to deduct that. You can directly get the energy absorption. How much amount of energy absorbed, and the unit is Newton meter, because the cross sectional area you have to measure it is in meter square, and the 1 joule which is equal to 1 Newton per meter square. Clear? Similarly for another material, this is for copper, brass. Now we have to apply it for copper. After that breaking, we will check what is the exact failure pattern of our material. Now again I set here just opposite direction, that is 300 kilonewton, 170, 170 sir, then it is 130 basically. And you have to check here the position of that specimen. You have to fix here, it is just like as a cantilever. See the groove here, and this specimen which is fixed as a cantilever beam. One end is fixed, other end is free. दिख रहा है कि नहीं दिख रहा? बताओ उसमें दिखाओ, नहीं दिख रहा है, नीचे करो, नहीं, हाँ अब दिख रहा है नीचे, हाँ. Now see here, one end is fixed and other end is free. The position of specimen. Okay, and in that groove side we have to apply that load, and in just opposite end char piece stays, we have to apply that load opposite side of our groove. Clear? Now see again as our dial gauge. So after releasing that hammer, what amount of energy it will be absorbed? So again from 170 here. So it is just after that 170, it is just about near about 155, isn't it? Similarly for mild steel, we have to perform the another test. नहीं माइल्ड स्टील है ना, टूट गया, माइल्ड स्टील ही तो चाहिए. चेक So be careful about the position of that hammer. That is important. Now we will check for mild steel material. And we have to check here the toughness of that mild steel material, which is more or less as compared to. This is the process how it can be fixed our specimen. माइल्ड स्टील ही चाहिए था पहले तो ठीक है सो वी हैव टू परफॉर्म नाउ चारपीस टेस्ट वी हैव टू चेक फॉर माइल्ड स्टील आल्सो हैमर की पोजीशन चेंज कर दो माइल्ड स्टील का बार फिक्स नहीं हो रहा है वी हैव टू चेक इट नेक्स्ट टाइम आल्सो इफ इट इज फिक्स then one more video I will prepare and I will share with you. But you know about how it can be calculated. It is just we have to apply the suddenly applied load and you can directly measure the energy absorbed, total energy absorbed. Okay, so for that we have to change the position of hammer for Charpy's impact test and same test the same hammer we have to apply it on the three different specimen here. This is copper, this is copper, this is brass and this is mild steel. This three specimen. Okay, now see here the groove is U now. Shape of that groove is U. These three different specimen. You have to measure the dimension also. And you can apply that load. It required 10 minutes to change the position of hammer and then we will continue. You can download any one video for Charpy's impact test from YouTube also, and we will check whether it is whatever experiment we have to perform here and whatever value you have to calculate here, whether that milestone value which is more tough than the other material. This is our impact testing machine. Only this machine in our laboratory, that is your our manually operated machine. So maybe in next year, this is also digital machine is there. Similarly, as per our tension, compression, and spring and torsion and hardness also. All the machines are our digital machine. Only this machine is our the manually operated machine. So maybe in next year I will change that machine. Because in Charpy's impact test, we have to require the angle of that position of that hammer is 135-degree centigrade. Again, the position of the dial gauge will also change for Charpy's impact. It is just opposite. Now, see, methodology is important. How it can be calculated, how it can be operate. These are the secondary things. So it's required again 4 to 5 minutes. Then we will start. We will continue. क्या हुआ? The position of hammer, that is important. Once you have to perform either Charpy's impact test or ISO impact test, because it totally depends on the groove or notch and Charpy's impact, whether it is applied from backside of groove or notch, and their inclination is also important. And the remaining part which is already given in our manual also. It is the methodology, the amount of that hammer, what amount of energy to be absorbed. It is just like our in bending and tension test, loading rate is there. It is also some energy absorption rate is also given 3 to 4 seconds per meter, because it is suddenly applied. In tension test, it is gradually applied. Now it is change the assembly which is required for that hammer. फास्ट करो जोसेफ जी, नेट चला जाएगा। देखना चेक करना। Now see the position of specimen. It is just like a simply supported. Okay. नीचे करो थोड़ा। हाँ. Now the groove, which is the opposite side of that striking of hammer. Clear? नहीं, 4 पीस है ना, ऊपर से देना पड़ेगा। जफर जी,
मेरे तो ठीक है तो काफी
now see the inclination of that hammer. That is 135 degree. Isn't it? So we have to check here. These 4 pieces impact. उसको निकालना पड़ेगा ना। हाँ। ये now see here what amount of energy it is absorbed during the performance of service. ये तो हिला ही नहीं। नहीं, 4 पी के लिए ऊपर से चाहिए ना अपने को। हाँ। अच्छा, दोनों उल्टा साइड से।
ये वाला हो गया।
उसमें भी नीचे से रखा था ना अपन ने, लेके
इसको भी इसी तरह करें। ये वाला जो है ना,
ठीक है,
ये वाला इसको भी।
अपोजिट साइड। ओके, चेक कर लो, बता दो, दिखा देंगे देखो। फास्ट करो थोड़ा, नेट बंद हो रहा है मेरा में।
ये रॉड लगा है। पहले मेरा तो शुरू है। मतलब ये बर्तन लगने का सपोर्ट के लिए। फिर थोड़ी आ रहा है।
खींचो और।
नहीं आ रहा। हाँ, अब आ रहा है। शुरू। छोड़ दो, छोड़ दो, छोड़ दो।
स्पेसिमेन फिक्स किया। हाँ, स्पेसिमेन फिक्स किया।
ये रखा हुआ है।
Now we have to check for mild steel. Huh? Now from 300 it is goes up to 180. So you have to deduct this reverse side. Similarly for brass material. Copper material. Now it is 250 for brass material. Okay. So then we have to calculate here the impact strength as per our formula.